Hi all, this is the MakeHaven badging video for the Wood Lathe here in the wood shop at MakeHaven. So the Wood Lathe is one of the more fun tools in the wood shop. It's similar to spinning pottery on a pottery wheel, for example, and it is also super useful in addition to being enjoyable. So the times when you might use a lathe are when you want to make things like this up on the shelf. So this is more of a bowl profile, something that's wide versus something that's longer. This is called a spindle. But the unifying factor is that the workpiece is being spun and then you're doing work with your tool to that spinning piece. So versus normally you have a spinning saw blade and a relatively stationary workpiece, here actually the workpiece is spinning and then you're making cuts to the outside. So everything that you do is going to be cylindrical. It's going to be radially symmetrical. You can't, for example, just put a flat side on here. You would have to do that afterwards or on a separate tool. When you're using this, everything is being done all the way around the workpiece. So things like candlesticks and cups and bowls and wands and all of those sort of things are what can be done on the lathe. So first we'll go over the anatomy of the tool, just sort of what we're working with here. This is called the headstock. The head is up at the top, and this is the drive side. So the motor is down here, and it's driving this headstock. This is called the tailstock at the tail end of the machine, and this is used to support your workpiece. This is called the banjo, this piece that slides around and moves, and this is your tool rest, as you'll see, because the tool rests right on top of it. We have a bunch of tools. Before we jump into them, I'm just going to go over the safety points of note for the lathe. And the big one is that you may try, and you will try really hard to hold the workpiece in, and 99% of the time the workpiece will stay in there, but 1% of the time you won't do a perfect job and the piece will come flying out. And that's why it's important to wear a face shield in any situation where you think there's any chance the piece could come flying out. The face shield is in addition to the eye protection, it's not a substitute. There are some situations where you can be pretty darn sure that it's not going to come out, and in those this isn't required. So for example, if you're using a chuck in the headstock and you're using the tailstock, then it's pretty unlikely for the piece to come out. Or if it's really small, if you're turning like a little pawn for a chessboard, if that were to break and come out, it's not gonna be that dangerous. So in that kind of instance, you wouldn't need to wear the face shield, but in any other instance where you have any fear of a bigger piece coming loose, absolutely wear this, and this just hangs right up here. You, as with all other power tools in the wood shop, want to make sure there's no dangly things, no necklaces, no like droopy sleeves that'll get caught, certainly no gloves. Gloves are for carrying things, not for using tools. Gloves could get caught and pull your whole hand in versus just giving you a cut on the one finger that gets touched. And so in addition to the workpiece coming out, you're going to be using a tool like this. And as with all tools in the wood shop, it's important to use it confidently, because if you're holding onto this timidly, it's going to get wrenched right out of your hands. So you want to make sure you're holding onto it really firmly, putting it right into your side to have a good firm grip, and using it confidently. And that comes with practice, but you need to make sure that you get into that mindset so that the tool isn't yanked away from you. So in terms of the wood that you'll use on the lathe, there are the whole world of woods to choose from. However, some are better than others. So this is one case when using green wood can be a good thing. Green wood hasn't been dried yet. So if a tree's just been cut down, it's still green before it's been left for a few years to dry or put in a kiln. And green wood turns really nicely. So professional turners, a turner is someone who uses a wood lathe, will take a whole bunch of green wood and get a whole bunch of bowls, for example, to 75%, because it's really fun and easy to turn the wood when it's green. Then they'll let them dry for a year in a barn, and over that period of time, a bunch of the bowls will split. They'll break apart because that was just what the wood was going to do when it dries, when the water evaporates. But for the ones that don't, then they take them the last 25% and make them into beautiful pieces. Versus waiting, having all their pieces of wood, letting them all dry, seeing which ones crack, and then for the 75% that didn't crack, going and having to hog through all of that dry wood just is a lot more work. So that's one thing to look out for, is green wood. That means you can just use logs. So most of the time when people come to MakeHaven and say, oh, I have this cool tree that fell in my backyard, I want to use it, unfortunately it's pretty hard to work with green wood. But when it comes to the lathe, that's actually great. So if there's a tree cut down in your backyard and you can get it into a manageable shape and size, something like these kinds of things that someone brought by, then that can be great. Also, they sell wood specifically for turning, wood that's been stabilized. So that means that it's been impregnated with a resin to make it really sturdy. So if you go to Woodcraft or eBay or something like that, you can find wood, all these beautiful exotic types of wood that have been stabilized. You can also pursue stabilizing wood on your own. So you put it in a pressure pot with resin, you can explore and research and ask facilitators about stabilizing wood, because that can be a good way to take pieces and make them great for turning. If you want to do little fine details, it's important to make sure that the pieces are not going to break on you. Aside from that, hardwoods are generally better. The softwoods are just not quite as fun to turn because they're kind of splintery. But if you have a piece of walnut or maple, it'll make really lovely, beautiful curls that'll be very satisfying. Something like oak is a little more chippy, a little rougher. So that's sort of the types of woods you can turn. In the wood shop, you can also do things like plastic. There's some other materials that you can play around with. If you want to try turning them, just make sure to check with a facilitator to make sure that it's a good choice. When you're using the lathe, some people also like to use an apron. So this shop apron lives down here, and you can put it on, and this just protects you from all the shavings that'll come flying off. If you have tassels or whatever on your shirt, this just kind of keeps it all contained, and so you don't have anything that they could get caught in the lathe, and it just keeps your clothes a little bit cleaner. So this is a tool that some people like to use when they are using the lathe. Just lids down there. So for the lathe, there are two types of tools that you can use. There are high-speed steel tools and there are carbide tools. And from a scientific standpoint, high-speed steel is a type of steel that is made so that it can be ground on a grinding wheel and it doesn't become soft. Most steels, if you grind on a grinding wheel, become soft, and once a steel is soft, it's no good for cutting anything because it'll get dull really fast. That's the more traditional tool that is used, and if you would like to use high-speed steel tools on the lathe, we have them available, but that's a separate badge to watch because you need to know how to sharpen them. High-speed steel gets dull pretty quickly, so you need to know exactly how to sharpen those tools. If you don't, they don't work very well, and it's pretty dangerous to use a dull tool. So what we use is for most of the turning here are carbide tools. Carbide is a type of steel that stays sharp for a very long time. It's very brittle, so if you're using this carbide tool, you need to be very mindful not to whack it against any of these metal pieces because it'll chip and break very, very easily. But as long as you don't do that, it stays very sharp for a long time, which is really nice to not have to worry about sharpening your tools all the time. They don't make quite as nice of a cut. We don't have as many shapes as they have available in high-speed steel, so there are some drawbacks, but for a beginner, carbide's really the way to go. So start with carbide, and then once you feel comfortable with that, you can move on to high-speed steel. So now that we've introduced the carbide, we'll look at the different types of tools that we have here in carbide. This is the square one. So this is the roughing tool. And roughing in woodworking or metalworking means to remove the bulk of the material. It means you're just getting the general profile or shape. You're not doing the really nice finish smoothing work. So this square one is really good for just that, for just removing a whole lot of material. So we'll start with that one when we get cutting. The next one over is the smoothing piece. And so this is a circle, so it's good for smoothing things. Another nice thing about the carbide is, let's say eventually this does get dull, what you can do is loosen that bolt in the middle and just turn it a little bit, and now you've exposed more sharp carbide. So that's pretty neat. And last we have a detailing tool. So this is a little diamond shape, and this can be good for doing little coves and little, all sorts of little shapes, or as a parting tool. Parting means when you have your piece of wood and you want to cut it off, you can go in and just make a nice little peck to cut off your workpiece with. All right, so this is a piece of wood that I grabbed. that we are going to use, and it's a really light wood, but it is a hardwood still. It's called sapele. It's a African mahogany, and what you might notice is that it's still a rectangle, and eventually it's going to be a circle, but it's much easier to go from a square to a circle than from a rectangle to a circle. So what I'm going to do is I'm going to go over to the table saw, and I'm going to quickly show you a trick for making this into a square easily. So we have this piece of wood, and we want this dimension to be the same as this dimension, because this is the limiting factor. Our square, we want both sides to be the same length, and right now this is the shorter one, so this longer one needs to become shorter. So the trick is to first put this thing up against here, and then tighten it down. So now we've told it that the distance between the fence and the blade is the length of the short side. So now when we flip it, it'll copy that dimension to the other side. I'm just going to make this cut quickly. So now that we have this square piece of wood, I'm going to show you the first tool underneath here. And this is the center finder. So the center finder works very simply just by putting your workpiece in there, and then it shows you where to draw a line right down the middle. We'll do one from one corner, one from the other, and where those two lines intersect is going to be our middle. So I'm just going to grab a pencil. So here I'm just going to draw this line and the other, and then if your piece weren't a square, then you just need to draw two lines from corner to corner, and wherever they meet is going to be the middle of your workpiece. So now we have that center, and I'm just going to do the center. And it's important to find the center, because when you're spinning your workpiece, if it isn't centered, if it's spinning from, say, some point over here, then it'll be wobbling all around, and that'll just not work. If you're off a teensy bit, it's okay. If it's a little bit wobbly, that's okay, because as you start removing the material that's off-centered, it'll become centered, but then you're losing more material than you need to. So now we're going to look at how to hold the work in here. So that's pretty important, and conveniently we're already set up with the pieces that we need in the headstock and the tailstock. So what I'm first going to do is loosen this in the back, and by lifting it up, it's pretty tight, I'll be able to move it backwards. And the first step is to take this piece. This is called the spur drive. These are little spurs. And take that center point, which is spring-loaded, and line it up with the crosshairs. And now what we can do is bring the tailstock in. And same deal with the tailstock. That point is going to sit right in the middle. And I'm just going to show that this is magnetically attached so that it clicks on there. So you could remove it if you wanted, but it's nice because what this does is it applies force to a more broad area instead of this point just splitting your piece of wood wide open. So now I'm going to bring that in and line that right up. And now I'm going to take this and lock it down so it doesn't go anywhere and crank this in. And what this is going to do is it's pushing this piece in to engage the spur drive up at the headstock. So now it'll have a good grip. And at some point what will happen is this slips a little bit. And so then you just really tighten down. So maybe, ask for help or get pliers or something to really tighten down, and then you can get a firm grip. And then once you're good, then you tighten down on this, so now this doesn't move away on you. If it's vibrating, this can vibrate loose on you. Great, so now our piece is held in between the headstock and tailstock, and this is called turning between centers. So we have center 1 and center 2. The alternative is using a chuck to hold the piece, and then not using the tailstock, and then it's just turning in the air. But in general, we don't like to do that with long pieces. A long piece really should be held at both ends between centers. It's only if you're doing something that's pretty short that it's okay to hold it just from one end, because it's less likely to get a crazy wobble and fly out on you. Before we get cutting, we're just gonna check to make sure the speed is reasonable for this. Similar to a lot of other tools, the same ideas hold, that you want higher speed for smaller things, and once it's really smooth and stable, then higher is okay for like sanding especially. But if it's a bigger thing, then you need to go slower. If you imagine a bigger thing, it needs to be able to make the turn all the way around one rotation in the same amount of time if it's set at the same speed. And for a bigger piece to do that, it needs to move really fast. So when you're cutting a bigger thing, you set it to lower RPMs so that the speed that the blade is touching your piece of wood at is the same. So this is a relatively skinny piece, so we can err on the higher side, but still super rough. So we don't want to go too fast, or else it's going to be really chattery. So I'll aim for like the second highest. So we'll check down here, and on this one we have to change the speeds manually. So underneath is the motor, which can be a little hard to see, but there's a motor, and it spins at one speed. And then it has two pulleys, here and here. They're step pulleys with different size pulleys on them, and it works the same as a bicycle. So on the when you're pedaling a bicycle, when you're cranking along, that front set of gears, if you want to go faster, you set it to a big chainring in the front and a small one in the back. And that means as you're pedaling, you make one pedal with your bicycle pedals, then the wheel in the back will make multiple turns because it's a big gear turning a small gear. Then if you're climbing up a hill and you want it to go slower but have more power, then in the front you go to a smaller gear and you turn that little small gear a few times to make that back big gear go around just once. So it's the same idea here, and I've written it up here. So going to the left, moving the belt to the left is faster, and to the right is slower. And we always want to keep the belt straight up and down so it isn't going crooked on us. So if we look down here, maybe try to think to yourself if you can see what speed this would be. Is this going to be a faster speed or a slower speed? This is going to be fast, because we're using the biggest pulley to turn the smallest one. So one rotation of the motor is going to be like 2 or 3 rotations of your piece of wood. And I don't want to go quite that fast. So what I'm going to do is lift up on this belt and then just drop it into there. And then from underneath, I'm going to lift up the motor and lower it down. Yep. So from underneath, I'm going to lift up the motor and slide this belt right into that pulley. So now it's just going a little bit slower, which will feel a little bit safer. If it was going at full tilt, it would just feel a little bit intense. All right, so now we know how to change the speeds and our piece is in there. So we're gonna start by roughing out the piece of wood just to make it a cylinder. So here's a little light that we can use. You just tap the back, and it's just nice to have a little extra light. There is a vacuum here, but frankly, it's not going to do much when we are removing a lot of wood. The vacuum is really good for sanding to get up little sanding particles. When you're removing a lot of wood, it's going to make a big pile of shavings. It doesn't make dust. It makes big shaving chips, and those you'll just sweep up with a broom and vacuum up. So this we can save for later. So now we're going to look at this tool, and I'm going to put the face shield on. So this just has a knob in the back, so I'm going to loosen it up and then tighten it down. And I'm going to lift it until we start cutting. So this blade needs to be facing upwards, so it's going to rest just like that. You can maybe tilt it a little bit, but no funny business like that or upside down. The wood piece is going to spin like this, so we want it to be coming down into the wood. And then with carbide, we want this blade to be right at about the center line of your workpiece. So it looks like I'm just going to raise this up just a hair to get closer to the center line. And you do that just by literally lifting it up and then tightening it. And then the banjo placement is also important. So number one, we really don't want the tool rest hitting anything spinning. That should go without saying. And it looks like we're clear right now. So we've met that level. Next, this is a big lever arm, if that makes sense. So this workpiece is pushing down on this end of the lever, and we're pushing down on this end of the lever, and we want to win. We don't want this thing overpowering us. So that means we want to make this lever as short as possible while still giving us enough maneuverability. So this looks like about 3/4 of an inch to me of distance between our workpiece and the tool rest, and that looks pretty healthy. But if we had it further away, if it was out here, then what could happen is this could grab us and just toss us right up. So you want to keep this distance pretty short. If you wanted to move it, which we will, then you just use a wrench and loosen this, and then you can move it wherever you want. Sometimes you'll want a shorter tool rest, so we have a little tool rest down here for a little piece, so you can drop that in. you could move this around. Let's say we're making a bowl, you're holding this. You could turn it 90 degrees so that you are cutting into the end of your piece. Or if you're sanding or drilling a hole and not using this tool, you just remove it all together. But right about here was looking pretty good to me. So I'm gonna clamp that back in place. And you'll notice I'm bearing in mind to keep this tip away from all the hard metal pieces so we don't chip it. Okay, I'm just gonna straighten it out so it's parallel to the workpiece. And we're good to go. So I'm gonna badge the tool on. So I'm just gonna pull this pedal out a little bit so it's easier for me to get to. And bring this down. And I'm gonna turn this power switch on. We turn this off. If I was ever gonna be working in here, moving things around, I would just flip this off so that I couldn't accidentally step on the foot pedal and get hurt. It's just easier to do this instead of keying out of the system and having to swipe back in. So I'm gonna turn you on. And first we're gonna check for stability. So I'm just gonna push the pedal and make sure it sounds pretty good and not like super wobbly. And that sounded really good to me. It wasn't like a thump, 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 thump. Didn't sound like it was about to fly out. It sounded nice and smooth. This whole table wasn't chattering, anything like that. So my first goal is just to make this smooth, to make it into a cylinder. So I'm gonna start by doing that. My left hand is up at the front. I got my thumb on top. I could have my hand on top if I wanted to be really aggressive. My back hand is on top, and this is somewhere near my hip. I feel pretty confident that I can hold this, but if you don't, if you're turning a big log or something and you want to have a really firm grip, you can put it right in your side. And when you're using the Carbide tools, it's important to keep the tool pretty much parallel with the floor. So when you're holding on to it, that's about where you should aim. You can go a little higher, a little lower, but in general you want to aim for parallel. And then if you're left-handed, it would just be in reverse. Or whatever is more comfortable for you. So you could have your left hand in the back and turn like that, whichever way you like. The really important piece is just to make sure that one of your hands is way at the back. When you're turning this, it can be really easy for this piece of wood just to catch here and whoop, and so you want to have as much leverage as possible all the way back here. I like turning with my hand like this just because I feel like it gives me a lot of control, but sometimes people like going like that. So we'll start cutting now. And now I'm going to do a trick that will test if it's circular. So I'm going to rest this on top, and if it sounds clattery, like you can hear a flat spot, then it's not a circle yet. So you can still hear a little bit, like right there, it's definitely not a circle. So we'll keep going a little bit. And sometimes a wood chip just gets caught right in there, so I'm just going to go like that. And you want to be careful to make sure that this doesn't hit the metal piece. All right, so now it looks like we have a circle except for here and on this side. So that means, yeah. So we're just going to do a little more. And I'm not sure if you can tell in the camera, but this wood is actually making some dust. So you could use the vacuum and that would help you get the dust out of the air. And it looks to me like now we have a cylinder everywhere except this little patch. And as I said before, I'm not going to get too close to this because I really don't want to totally destroy this tip. So we're not going to get all the way to the end. This is a piece that we're just going to hold it by so we can cut it off there. We're not really going to worry about getting all the way up to that end. If we wanted, what we could do is make what's called a tenon here. So a tenon is a piece of wood that fits into a mortise normally, which is a hole in the same shape. In this case, we could make a tenon that a chuck would hold on to, and so that would let us get to the other end of this without using the tailstock. But this is a really long spindle, so we're not going to probably do that. But you can see that's what they did here. So in this piece, they had it mounted up one way or the other, and then they came here and used the tool to make this tenon, so they could flip it around and hold it just by here with no tailstock, and then they can get in here and make a nice bowl. So that's why you would want to use this opportunity to give yourself a tenon to hold on to from the other side. So I'm just going to finish this little bit here. And now we have a circle. So I'm quickly going to show you the other tools, and then I'll show you the other ways of holding on to the material. So next we have the smoothing tool. And as with all three of these carbide tools, you can tilt a little bit one way or the other, try going up and down, but you don't want to try to do anything crazy. You know, it's really just a few degrees of movement in each direction can give you a different kind of cut. So there are a few things to see here. So this is called a cove, and a cove is made when you make an indentation in the wood like that, and this is called a bead. A bead is when you have a raised piece. So you can make all different kinds of coves and beads, and that makes all kinds of beautiful things for banisters and for chair legs and things like that. And you can also just generally smooth with this. So if you go along, it'll just leave kind of a bit of a smoother finish than it did with the roughing tool. Last, we're going to look at the detail tool. And what this does is this can just make nice little details, or you could use it as a parting tool. So that isn't super relevant between centers, but let's say we were holding this in a chuck, which we will in a minute, and then you wanted to cut it off. You wanted this to be your final piece, and so the tailstock we can pretend is no longer being used. Then you go all the way to the middle until your part falls off. So it parts it separates it from the rest. But I'm not going to do that now because we're between centers. And obviously you can't use the spur drive not between centers, because if we move the tailstock away, this will just fall off. It's only being held on the spur drive because we're using the tailstock. So we're going to try this. So in my experience, this tool cuts much better instead of just pushing straight in when you can get so that you're working sideways. It cuts much faster. You can see here that we're getting to a pretty small diameter, so you need to be careful to do all of your big diameters first. So if we were doing some kind of shape, we would do all the things where we still left a bunch of wood in the middle, and only at the very end do we do the ones where we get just down to the middle, because if you start with this little guy, and then I start hogging material out over here, this piece is twisting, and then I'm applying a force over here that's trying to stop it from twisting, and I could snap at our little thin point. It's not being driven from both sides, it's just being driven from this side. So if I'm trying to do a big cut on the far side, it could just break. Over here it'd be fine because this isn't being twisted. So now we're going to look at the different ways to hold the material. As I said, this is called between centers using the spur drive. And we're just going to look down here because this is where those pieces live. So let's say we came along with this chunk of wood and we wanted to hold on to it somehow. One way we could do that is with a faceplate like this. So this guy, you just screw right in, and now you stick it on there and you can spin it. But then you end up with 3 screw holes in your piece of wood. So let's say we're making a bowl out of this. The way you do that is screw this in here and then stick this on, which we'll show in a minute. And then you do whatever shaping you wanted to the outside. And I would do most of the heavy shaping first because this has a really good firm grip and get it nice and stable. And then the last step this is going to be the bottom of our bowl, is I would make a tenon on here to hold on to it with, remove this, flip it around, and then use the chuck, which we'll see, to hold on to this, and then this we can carve out. So where those 3 holes were, we can remove that wood. So that's how we'd use this faceplate. There are bigger ones, smaller ones, different kinds down here. Then these are 2 chucks. So we're going to look at this chuck first. This is called a self-centering chuck. That'll make sense in a minute. So I'm going to remove this. I've turned the switch off so I can't accidentally step on this and hurt myself. I'm going to loosen here. Whoop. And then this just dropped out. So we're going to move this back. And we need to remove the spur drive. So to do that, we're going to use this metal rod. I call it a ramrod. It may have a more technical term. And we're just going to pop this right out, pushing from the back. Just like that. And you just want to have your hand here, else it'll fly out on you. And we can put this spur drive back down here. And now we're going to put this in. So just going to move our tool rest and thread this on. However, you'll see that it's just spinning on me. I can't tighten it. So we need to lock this somehow so that I can tighten it. And we do that with this pin. So this pin goes in, and from the back side, it sticks in a little hole in the pulley wheel right down here. So this little pin goes right in here, and now I can tighten and it won't turn on me. So that's nice. And then we can remove the pin so it'll spin. If you forget to remove the pin, you'll push the pedal and it's not going to spin because this pin is stopping it. So now this is on there. And here, this is our chuck key. And confusingly, it goes backwards, in my mind at least. So here, it's righty-loosey. So we're going to loosen it up by turning clockwise. And take our piece of wood. I'm just going to take this out for a minute. And there are a whole bunch of different ways to hold this in here. So you could hold on the inside of something. So you can see with this piece, they made a little pocket here, so they could hold it like that. Or you can hold something on the inside in between these teeth or in here. Since we have this little piece, we're going to hold it. You could do any one of these. We could hold this square piece in here or a circular piece in here. I'm going to hold the circular piece just because it's a little easier. And then we're still going to use the tailstock because it's a long piece. If it was shorter, then we wouldn't need to use the tailstock. But as it is, it could go flying all over the place. So I'm going to bring the tailstock back, push it right in there, lock it down, snug it up, and then turning to the left, tighten that. And now this is held really firmly in there. So that's one good option for holding your workpiece. More often than not, you're probably going to use this chuck when you're not using the tailstock. You're going to be holding this thing really firmly on a tenon that you made when you were turning between centers in your first step. So that's the self-centering chuck. Next, we will look at the non-self-centering chuck. This has 4 teeth on it. This can again hold on the inside of a circle or on the outside of a circle. And each of these gets adjusted individually with this key. So this is just the key that it uses, and you tighten and loosen each one individually. So this is good for bigger pieces. It's also good if something isn't quite a perfect circle. So if you have some weird shaped log, holding it in the middle, which is what this would do, it may still be really vibrating. So this will let you hold it in such a place that it isn't vibrating. technically the center of mass isn't aligned with the middle of the end. And you want to have the center of mass aligned, not necessarily the end. So this goes on the same way. And this chuck comes off the same way. You'd put the pin in and just twist the other way to loosen it. And looking down here is another cool tool. So this is called a keyless chuck. Both of these use keys, but this one doesn't. And this keyless chuck is similar to on a drill. And what this is for, it can do a few things. One, we could remove our tailstock. And with the tailstock, this right now is holding what's called a live center. It's called live because it can spin. But let's say we don't want that. We want to put this in instead. We're going to loosen this and then screw this backwards. And when we go far enough back, it's going to pop this out. This has what's called a Morse taper on the backside, and that's just held in by friction. So I'm going to put this down here and put this in. So we're going to screw this back out a little bit. And this guy, when you put in something with a Morse taper, you just give it a firm shove and it's stuck in there. So now what you could do is put a drill bit in here and tighten it up. And then let's say we wanted to drill a hole in the end. Maybe we'll get a drill bit. We're going to take this drill bit, put it into the chuck, just like that. And now it's a little funny to see, but the workpiece is going to be spinning and the drill is going to be sitting still. So we're going to line this up right with the middle, and just so that it isn't wobbly on us. Then lock this down. And here we're not using the tool rest, so I'm just going to remove this. And then we're going to keep this loose because we're going to push the drill bit forwards with this handle. So now I'm going to turn it on. And what I'm going to do is tighten this up just a little bit so that it isn't wobbly. And now pushing here, we just drilled a hole in the end of our piece of wood. So that was pretty cool. For me, it's kind of bizarre to see the drill bit not spinning and it working as a drill bit. Alternatively, we could put this keyless chuck in the headstock. So let's say we were turning a pen or something really skinny and small, and it was too small to hold in one of the other chucks, then you could hold it right in here as though you were holding a drill bit. So that's what this can be for. And another one is a woodworm screw. So this is an alternative to a faceplate. A faceplate normally puts 3 holes in, but if that was too many for you, then what you could do is drill a hole in here and screw this guy in here, and then you just have 1 hole right in the middle. That's not quite as good because it's easy for these threads to strip out of the wood, but it's an okay option for getting a bite into your piece of wood. Alright, so now we're going to look at sanding and finishing our piece. So I'm going to re-engage the tailstock because the spindle needs to be supported. I'm just going to advance you, and we have our hole there now. So what that means is I'm going to take off this little guy because right now I can't really find the center. So when I take this off, this big point can go in there and beautifully find the center for us. Lock that, lock you, lock you. I'll just I'll just put this down here for now. And for sanding, you need to make sure that the tool rest is not in. If the tool rest was in, it'd be very easy to get your fingers caught in there. There's no reason to have it, so you just get rid of it. 2, we want to make sure the vacuum is on. So this vacuum hose attaches to the bottom of this blue tube. So right down here. And when we use a piece of sandpaper, so here's some sandpaper, you always want to start with the lowest number that you need to. So here I don't see any huge gouges, otherwise you might start with like a 60 or something, but I think it's 80, which is fine. And you want to remove everything that you can with the 80 grit and only go up to 100 or 120 or whatever once you've thoroughly removed everything that the 80 can do. So I'm just going to tear off a piece of this. And there's actually a lot of friction here. So this gets really hot. So I'd recommend moving around and not putting your finger right behind where you're pushing because it'll burn you. So in general, I try to have it extended beyond or hold it like this. And I'm also going to pull up my sleeves because my hands are going to be really close to the material. So I'm going to turn the vacuum on. It'll be a little loud for a second. And then I'm just going to go down, and something that is important is it's spinning this way. So I'm going to make sure to hold it from this side. If I were to try to go on the top holding here, it's just going to grab and push down into my fingers. So I'm going to let it drag along the material. I'm certainly never, the big no-no is wrapping this around a finger, because it grabs and it'll just do some nasty things. So we don't do that. So you just hold on to it. So if it does grab it, it just pulls it out of your hands and no harm done. You can get in little crevices. You can make a little cove shape to get inside the coves, just like that. But often you just want to let it drag. You don't want to try to be pushing your thumb up against it or something like that. So this is on. I'm going to turn the vacuum on. So I'm not going to sand the whole piece. There's no need for that. I think that probably made it rougher using this, because it actually had a really nice finish to begin with. So I could have started with a 150 grit, or maybe 220, and that would have been the better option. You could see maybe that still had a little wobble to it. So that just meant the drill bit wasn't perfectly centered when we made that hole. And then in terms of finishing, there are a few options. Obviously you can take it off and do whatever kind of normal finish you want to do. Where finish means how you treat the wood. If you want to protect it with a polyurethane, if you want to just make it water resistant. I recently made a rattle for a baby, so I needed it to be food safe so it could go in a baby's mouth. You need to finish it somehow, otherwise all the water, or saliva in this case, would get into it and just make the wood stained and kind of nasty. So the two finish options are mineral oil, and mineral oil gets absorbed into the wood and then just kind of disappears. That's what we use on cutting boards traditionally. And beeswax. So I chose beeswax because what you can do is just take a chunk. This is beeswax that just lives down there. And when it's spinning, it actually causes so much friction between this chunk of wax and the wood that it heats it up and melts right into the wood and creates this lovely finish where the beeswax helps protect the wood a little bit from moisture. It's fine if it gets in someone's mouth, and it's really easy to apply. It's not like a high gloss finish, it's just sort of a low luster. So I'll just show you for a second what that looks like. So maybe you could see that after a second, it just got a little darker as it started to melt. What might happen is you apply too much, and then we just have a rag down here. And this is very important. You really just, it's tempting to wrap this around your finger. Don't do that. You can fold it up and then apply it with the face of your hand. So if there is too much beeswax on there, you can take this. Another trick is with hardwoods, especially when you have big shavings, is you can take those shavings and very carefully, again with an open hand, making sure you're not gripping it, you can apply those. And those will actually help to polish the wood. So those are a few finishing options. It should go without saying, but I will say just to reinforce that anytime you have your hands really up close to this piece, bear in mind there's a big spinning chunk of metal. So you catch a finger in there and it's just gonna, it's really not gonna be fun. At the very least, you'll lose a nail. So just be very mindful of where your hands are when you're sanding, keeping your fingers away from those spinning metal pieces, and that'll make sure that you have a more pleasant time using the lathe. You can reposition this guy just as a note. So if you're making a bowl and you want to be able to see inside of it, you can tap this to get it brighter or dimmer. And once you're comfortable using the Carbide tools, I encourage you to learn about using high-speed steel, because that's a whole nother world that lets you get to even higher levels of artistry using wood turning. And obviously this just gets a little bit of the sawdust so it doesn't get in your lungs, but the wood lathe makes a whole lot of wood chips and shavings. So when you're done, make sure to get the vacuum, unplug it from this guy, clean up all the bits and pieces on the tools under there, underneath, and all the way, say in a 5-foot radius to make sure you get everything all around you, and maybe even do the person next to you a favor and clean up a bit of their mess too. And that'll help make the shop a more pleasant experience for everyone. Thanks for watching.